Okay, here's a pair of problems that are related. The first one says a car slows down from 45 meters per second to 30 meters per second. So let me just start writing what I know. My initial velocity was 45 meters per second. My final velocity is 30 meters per second. My time is 6.2 seconds, and I'm looking for a distance. Don't know that. Well, check to make all my units are the same. We've got meters and seconds, so that looks good. Let's see. Now I know there's a formula because I read the chapter. D equals VOT plus 1/2 AT squared. That's one way to look at this. The problem is we don't have the A. So what's a way that we could find the A? Well, if we take VI plus VF and we take half of that, that would be our average, and then we multiply it by our time. If we opt for average speed divided by time, that's going to give us our distance. So this would be a formula that we could use on this one. Let's see what we've got. D equals 1/2. VI is 45. Now in this case it doesn't matter if you switch them around because they're just added together. But in some cases, it'll matter if you get VF in the wrong place or VI in the right place or what have you. But 45 plus 30 meters per second. Let's do our unit analysis too as we go here. 6.2 seconds. Let's see, this is going to be meters per second times seconds. So the seconds in the bottom are going to go away, and I'll just have meters and half of meters. Well, gosh, that's a way to measure distance, so we must be on the right track. And when we type that in the calculator, I get 232.5 meters. Okay, now the second one down here is cyclist speeds up from 8.4 meter per second pace. So that's my VI in this case. So I'll say VI equals 8.45 meters per second. And as he accelerates, okay, so he's accelerating, oops, that should be an A. I don't know what that is. He goes from 325 meters, that's D, 325 meters, in 30 seconds. Now, let's see, that should be T, not S. T equals 30 seconds. All right, let's see. We don't know what the A is in this case either, so that first formula I threw up there, that won't work, but this one works just fine. So let me write the formula down again, because I'm going to manipulate it. It's always good when you're doing your homework to show me what equation you started with and what you did to it so that I can follow where you're at. Okay, we want to solve this because we're looking for his final velocity. And I should down here put VF equals question mark. I'm going to cross this out because I'm really not looking for that. I can find it, but I'm not looking for it right now. Okay, so I'm going to solve this thing for VF. Well, how to do that is I'm going to move the 2 over there, so I'll get 2D. And then I'm going to divide by the T. Maybe not do too many steps all at once. I get VI plus VF. Okay, if I want to get rid of the VI, I'm going to subtract it. So if I say 2D divided by T minus VI equals VF, let's do a unit analysis on this as we're looking at it. This would be meters per second. Up on the top we've got meters, on the bottoms we have seconds. This would be meters per second. So I'm going to end up with meters per second as my units. So let's see, 2 times 325 meters and 30 seconds. Then I'm going to minus 8.45, and I ended up with 13.2 meters per second. Now, the problem says that he's speeding up from this pace, so if I got a number lower than that, I'd question whether I did it right. 13's higher, it's really fast paced, so it makes sense.